Hello children and welcome to today's class. Just a little reminder, we have been learning about safety and first aid right from grade 1. We have learned so many times that you should not touch electrical appliances with your wet hands. We have also learned that we should not plug in into a socket while the switch is on. You should always switch off the button and then insert a wire. Why are all these instructions given to you all the time? This is because electricity can cause an electric shock to your body. Now, electricity, other than providing you heat, light, and cooling, can also produce chemical effects. This is exactly what we are going to talk about in this chapter on chemical effects of electric current. Now, before we proceed into this chapter, let us quickly revise what we learned in the chapter of some natural phenomena. We learned that there are electrical charges in every body. The number of negative charges and positive charges are the same. That is why the bodies are usually at neutral. But sometimes when two bodies are rubbed together or brought in contact with a charged body or brought close to a charged body, it can acquire charges. So this charge that a body acquires becomes the electrical charges. And if these electrical charges are continuously flowing from point A to point B, they become electricity. So, electricity is actually an invisible form of energy. Electricity is of two types. The first type is static electricity and second type is current electricity. स्टैटिक इलेक्ट्रिसिटी के बारे में आप ऑलरेडी पिछले चैप्टर में पढ़ चुके हैं जब हमने अपने सर के ऊपर कोम मारी थी दैट कोम बिकेम इलेक्ट्रिकली चार्ज और जब उस कोम को हम पेपर बिट्स के ऊपर लेके आए थे द कोम बिगैन टू अट्रैक्ट those bits of paper. It was attracting the bits of paper. That means the comb and the bits of paper were together charged. But अगर हम comb करके सिर्फ comb को रख देंगे, the charges will still remain inside the comb. They will then be called static electricity. Now, most bodies around us, as I just said, are made up of atoms. Now, these atoms are actually the ones which are positively or negatively charged. How? Let us understand through this picture which is given in your book. So, the basic structure of an atom consists of a central nucleus and outer orbits. न्यूक्लियस के अंदर दो तरीके के सब्सटेंसेस होते हैं. फर्स्ट इज प्रोटॉन, द सेकंड इज न्यूट्रॉन. न्यूट्रॉन न्यूट्रल होते हैं, प्रोटॉन्स पॉजिटिवली चार्ज्ड होते हैं और आउटर ऑर्बिट पे घूम रहे होते हैं इलेक्ट्रॉन्स. ये इलेक्ट्रॉन्स नेगेटिवली चार्ज्ड होते हैं. अब समझने की बात ये है कि जितने पॉजिटिव चार्ज यानी कि प्रोटॉन होते हैं उतने ही एक एटम के अंदर नेगेटिव चार्जेस यानी कि इलेक्ट्रॉन्स होते हैं. बट अगर इलेक्ट्रॉन्स को किसी के साथ रब करके निकाल दिया जाए तो इलेक्ट्रॉन्स कम हो जाएंगे और प्रोटॉन्स ज्यादा हो जाएंगे. तो ये एटम क्या हो जाएगा? पॉजिटिवली चार्ज्ड. ऑन द अदर हैंड अगर हमने किसी ऑब्जेक्ट को रब किया और उसने इलेक्ट्रॉन्स गेन कर लिए, उसके पास बाहर से इलेक्ट्रॉन आ गए, तो इस एटम के अंदर इलेक्ट्रॉन्स का नंबर बढ़ जाएगा. इट विल बिकम नेगेटिवली चार्ज्ड बिकॉज प्रोटॉन का नंबर कम हो जाएगा, इलेक्ट्रॉन्स का नंबर ज्यादा हो जाएगा. टिल नाउ वी हैव लर्न्ड this transfer of energy by rubbing or by friction. Now we are going to understand how this flow of energy can be continuous. The flow of charges can be continuous, जिसकी वजह से electricity develop होती है. We know that charges flow from one direction to another. Now, what is that direction where the charges flow? So let us understand first that there is a difference in electric potential in two different objects. The charges will begin to flow from a positively charged body to a negatively charged body. क्योंकि positively charged body high potential पे होती है, इसलिए negatively charged body के negative electrons positive की तरफ जाते हैं. When we are able to maintain this flow of electric charges continuously in a stream, it is known as electric current. इलेक्ट्रिक करंट के लिए दो चीजें बहुत जरूरी हैं. नंबर वन, इलेक्ट्रिसिटी का जो पाथ होता है, जो सर्किट होता है, दैट हैज टू बी कंटिन्यूअस. अगर वायर बीच में से ब्रेक है या स्विच ऑफ है तो इलेक्ट्रिसिटी फ्लो नहीं करेगी. द सेकेंड इंपॉर्टेंट थिंग is that we need a driving force to keep pushing these electrons towards the positive charges. ये कैसे मिलती है? ये हमें मिलती है बैटरी से. So what is the direction of flow of electric current? अभी मैंने बताया that a positively charged body is at a higher potential. और जो चार्जेस होते हैं वो हमेशा हायर पोटेंशियल की तरफ जाते हैं. दैट मीन्स नेगेटिव चार्जेस हमेशा पॉजिटिव की तरफ जाएंगे. सो व्हाट इज द डायरेक्शन ऑफ फ्लो ऑफ इलेक्ट्रिक करंट? ऑलवेज फ्रॉम द नेगेटिव टू द पॉजिटिव टर्मिनल, as you can also see in this circuit diagram. In this circuit diagram, the pink arrows actually tell us the direction which the electricity is taking. You can see that electricity is flowing from the negative terminal to the positive terminal. There are two kinds of substances all around us. There are conductors and there are insulators. Conductors कौन हुए? Conductors हुए all substances like metal which can conduct electricity through them. और insulators क्या हुए? Materials that will not allow electricity to pass through, like wood, plastic, etc. This is the reason we just studied in the beginning of this chapter कि जो कॉपर वायर्स होती हैं उनके ऊपर प्लास्टिक की कोटिंग क्यों होती है? So that the electricity is not transferred to us if we touch the wire. Plastic absorb the electricity, they do not let it pass through them. We have studied till now that electricity passes through conductors. Now let us understand, is water a good conductor of electricity or not? So pure water, which is distilled water, which has got no impurities, no other minerals, it is simple H2O. It is a bad conductor of electricity. We will conduct a small experiment to understand how we can make water a good conductor of electricity, and we are also going to understand what are the other liquids through which electricity can pass through. Liquids can be poor conductors or good conductors of electricity. Take connecting wires, a bulb, and connect them as shown. Touch the bare ends of the wire B and C with one another to check if the electricity transfers properly. If it does, the bulb will glow. Now we dip the bare ends of the wires B and C in a beaker containing distilled water. You will see that the bulb does not glow, as distilled water is a poor conductor of electricity. Now to the above water in the beaker add a spoon of common salt after removing the wires. Now again dip the free ends of the wire B and C in salt water. You will see the bulb glows. This proves that addition of salt makes distilled water a good conductor of electricity. You can also check whether liquids like lemon juice, tap water, vinegar, alcohol, petrol, diesel, dilute hydrochloric acid are good conductors or poor conductors. In the same experiment, we have to replace the salt water that we just added and add these liquids one by one. But we have to remember that every time we put the wires into a different liquid, we must clean the ends with the help of sandpaper. So as we can see, if we pour lime juice inside the beaker and dip the wires, the bulb glows. That means lemon juice is a good conductor of electricity. So children, through this experiment, we have understood how different liquids conduct electricity. In some cases, the bulb glows, and in some cases, the bulb does not glow. Now, this was about transfer of charges that lead to electricity. Let us understand now the chemical effects of current. Before we understand the chemical effects of current, we need to understand about electrolytes. Electrolytes क्या होते हैं? कोई भी जो compound होता है, let us for example take a compound A and B. अगर इलेक्ट्रिसिटी पास होने पर ए और बी ब्रेक अवे होके आयनाइज हो जाते हैं, तो वो कंपाउंड को बोलते हैं इलेक्ट्रोलाइट। जब हम इस कंपाउंड को पानी में डाल के इलेक्ट्रिसिटी पास करते हैं, समटाइम्स दिस split into ions is 100%. In that case, these electrolytes will be known as strong electrolytes. Now, strong electrolytes are hydrochloric acid, sulfuric acid, nitric acid. They can be also They can also be strong bases like sodium hydroxide, potassium hydroxide, or salts such as sodium chloride or magnesium chloride. Now, in case when electricity is passed through an electrolyte and it does not break up 100%, it only gives a little percentage of ions, they are known as weak electrolytes. Let us now take the example of weak electrolytes. So as we can see, weak acids like acetic acid, carbonic acid, phosphoric acid are weak acids, and weak bases like ammonium hydroxide are also weak electrolytes. There are certain substances like glucose and alcohol. ये substances water में तो dissolve हो जाते हैं लेकिन ionize नहीं होते हैं. These substances are known as non-electrolytes. अब हमने ये सीख लिया कि इलेक्ट्रोलाइट क्या होता है, हमने ये भी सीख लिया वीक इलेक्ट्रोलाइट कौन सा होता है, स्ट्रॉन्ग इलेक्ट्रोलाइट कौन सा होता है. अब इन इलेक्ट्रोलाइट्स की जरूरत क्या है वो समझते हैं. These electrolytes are used to conduct electricity. क्यों हमें इनसे इलेक्ट्रिसिटी कंडक्ट करवानी है? Because an electrolytic solution is a solution that conducts electricity, and this solution works as an electrolytic cell. Now, an electrolyte cell is a vessel in which positive and negative electrodes are present. Positive electrode को हम बोलते हैं एनोड और नेगेटिव इलेक्ट्रोड को हम बोलते हैं कैथोड. इन दोनों इलेक्ट्रोड्स को ऊपर से वायर के साथ कनेक्ट करके बीच में एक बैटरी फिक्स कर दी जाती है, जिसकी वजह से the ions begin to flow, and we all have studied that when the ions begin to flow, then electricity begins to flow. Now, when the current passes through an electrolyte, it breaks into its constituent compounds. इस प्रोसेस को इलेक्ट्रोलिसिस बोलते हैं. और इलेक्ट्रोलिसिस का यूज कहाँ पे है? सबसे पहले इलेक्ट्रोलिसिस का यूज है प्योरिफिकेशन ऑफ कॉपर में. प्योरिफिकेशन ऑफ कॉपर के लिए हम जो सोल्यूशन या इलेक्ट्रोलाइट लेते हैं, दैट इज कॉपर सल्फेट सोल्यूशन. हम एक प्योर कॉपर की शीट को बनाते हैं नेगेटिव टर्मिनल, और जो इम्प्योर कॉपर है उसको हम बनाते हैं पॉजिटिव टर्मिनल. इससे क्या होता है? जो पॉजिटिवली चार्ज्ड कॉपर है एनोड के ऊपर, वो इलेक्ट्रिसिटी पास करने पर ब्रेक अवे होके नेगेटिव की तरफ भागता है. इन द सेम वे all the pure copper ions are deposited on the copper sheet. This is how copper is separated from its impure substance, and all the impurities that were there in the impure copper sheet, they settle at the bottom. Another important application of electrolysis is known as electroplating. Electroplating का मतलब क्या होता है? A coat or a layer of metal is provided as a covering or as a coating to another metal with the help of electricity. Some alloys like brass can also be prepared by electroplating, and alloy has metallic properties. और जब हम दो elements को मिला के alloy बनाते हैं, that alloy turns out to be with better qualities than the original elements. अब इलेक्ट्रोप्लेटिंग होती कैसे है? जिस ऑब्जेक्ट के ऊपर इलेक्ट्रोप्लेटिंग करनी है उसको हम बनाते हैं कैथोड, मतलब नेगेटिवली चार्ज्ड साइड, और जो प्योर मेटल होता है जिसकी कोट हमने उस मेटल के ऊपर डालनी है उसको हम बनाते हैं एनोड. ऐसा क्यों करते हैं? क्योंकि हमने पढ़ा है कि हमेशा एनोड से कैथोड की तरफ चार्जेस जाएंगे। एनोड को बना दिया हमने वो मेटल जिससे हमने कवर करना है, और कैथोड बना दी हमने वो मेटल जिसके ऊपर कवर करना है। सो व्हेन करंट इज पास थ्रू, अपने आप जो मेटल की लेयर हमें कोट करनी है उसके आयंस जाके दूसरे मेटल के ऊपर स्टिक हो जाएंगे, एंड दे विल फॉर्म एन एंटायर लेयर over the metal which has to be electroplated. Uses of electroplating. Electroplating is done so that desired properties like resistance, corrosion protection, lubricity, and improvement of aesthetic qualities are brought out in the metal that is electroplated. Also, they become resistant to corrosion, they look attractive. सो क्रोमियम प्लेटिंग किस पे होती है? क्रोमियम की प्लेटिंग की जाती है टैप्स पे, कार के बम्पर्स पे, बाइसिकल हैंडल्स पे, विच मेक देम शाइनी। जिंक की कोटिंग करी जाती है टू प्रोटेक्ट स्टील. So these are some of the benefits of electroplating. So children, in this chapter you have learned about electricity, how electricity flows from one point to another. What are the requirements for electricity to flow? You have learnt about electrolysis, you have learnt about strong electrolytes, weak electrolytes, and the practical applications of electrolysis. Thank you.